presentation or not?
Yes, you can.
Okay. Okay. Good morning, everyone. So today, me and my group, including Marcel, Garda, Michael, Amar, and Rizky, will present about Apache SAMOA. It is a platform for mining in big data streams. And continue. So Apache SAMOA stands for Scalable Advanced Command Analysis. It search a platform for mining in big data streams, and big data is defined as datasets whose size is beyond the ability of typical software tools to capture, store, manage, and analyze, due to the time and memory complexity. Velocity is one of the main properties of big data. Apache SAMOA provides a collection of distributed streaming algorithms for the most common data mining and machine learning tasks such as classification, clustering, and regression, as well as programming abstractions to develop new algorithms. And the purposes of the Apache SAMOA is enables for the development of new machine learning algorithm without directly dealing with the complexity of underlying distributed streams processing engines, such as DSPs and Apache Storm, Apache Flink, and Apache Zamza. Apache SAMOA users can develop distributed streaming of machine learning algorithm once and execute them on the multiple DSPs. And for the importance of the SAMOA itself, the first one is this for using the spam detection in comments in email, and the second is trends that change that every time, and the third one is need to retrain the model with the new model, and it can also detect spam on Twitter. And for the agenda, the streams is for the application and model, and for the SAMOA itself, it is for the goal, example, and challenges. And the next slides will be continue with Edgar.
Hello, good morning. Would you mind for the next slide? All right, cool. So about application. So basically, this is what SAMOA do. You know, as everyone's as what Sarah told us before, it's a place to mine big data streams. So what do you mean by streams? Are basically imagine like maybe a waterfall but full of data. So they keep going continuously, you know, flowing through whatever the system is moving. So in application, they have three different kinds of, let's say, examples. For the first one is personalization. This is basically used in trending topics, or basically where you update this news when you go into a, let's see, a New York Times website, or a website that gives you an update news for a continuously time. That's what personalization is, especially when you have open them regularly. That's what happens in SAMOA. And spam detection is basically when you go through emails. When you go through email, there are a lot of spam in your email. So it reports with a large amount of data. And when it comes to recommendation, it's basically when the times when you guys are basically the times where we open up YouTube or maybe Netflix. Those recommendation are the ones that how do we say this, equally to our needs, because that's how SAMOA reads what we are trying to like. So basically, when we watch a lot about babies and stuff like that, the recommendation could be babies, and even sometimes ads through babies. Next tab. And big data stream, as I said before, are large big streams or large big amount of data, as in volume and velocity, which means like even a web company sees that the velocity is too fast for a single commodity server, and the volume is too large for a single for a server main memory. So therefore, a solution must be declared by using distributed and scalable. Next. Examples are, we can see that, the times when people are roaming around, surfing the internet and stuff like that, those are the data that we achieve by user clicks, query searching. Sometimes we search a lot of what's about a bunch of things that we sometimes don't need and stuff like that. Those are the things that um, the SAMOA reads, the news, the emails, Flickr photos, even Instagram, credit card transaction, and so on. Those are all the data that SAMOA reads to to understand what we as the user or a certain user needs, and how to accommodate those data. So basically that's what SAMOA does. Okay, next. Ahmad, it's your time. Please continue.
Okay, the stream is like the same as it works when it streams. When it streams, it keeps on batching data that makes snapshots of this data stream. The next one is data science lifestyle. There are 5 flows in data science lifestyle. The first one is deploy, old school's data mining. The second flow is gather, from data to insight. The third flow is clear, from insight to model. The next one is model, from model to value. And the last flow is repeat. The next one is concept. The first one is SAMOA is a platform, and the second one is researchers. The third one is framework from developing distributed stream mining algorithms. The fourth one, practitioners. The last one, library of state-of-the-art distributed stream mining algorithms.
And for the next part is the structure of the flow for data mining. It is divided into distributed and for the non-distributed. And in distributed, we have divided the batch and the stream, and it includes the Hadoop and Mahout for the batch. For the stream, it consists of the Storm, S4, Samza. It includes the SAMOA itself. For the distributed, it is divided by the batch and stream, and for the batch it is R and Wika and etc. And for the stream is MOA itself. And for the architecture, the SAMOA itself, it is include for the classification, clustering, and regression, and FPM. And for the SAMOA itself, it includes the Storm, S4, SAMZA, and local. And continue with Edgar for the next slides.
Okay, in the status part, parallel algorithm are used in some at times like this. There's also vertical hoofding tree, clue stream as in the function of clustering, adaptive model rules in regression, pharma, frequent pattern mining, it's at mean time and spending, execution engine storm as for some plus local. Basically those stuff that are explained before as as a as in the distributed part, I think. Yeah, in the distributed part. Okay, next. When we're looking for something useful, as in the somewhat useful at this kinds of time, it is useful only if you need to deal with like big fast data, as in news and stuff like similar than that, evolving data, model updates, or trending topics, what is happening in real time, using feedbacks in real time, adapt to changes faster, and more on recommendations, stuff like that. It is it is frequently useful at this kind of time. Okay, next. In advantages, in basic and operational issues, they use them like program once and run everywhere. So they manufacture it once and it can run the entire time. Reusing existing computational infrastructure, avoid deploy cycle, and sometimes they don't have no system in as in the downtime. So basically, it runs every time. No complex backup update procedures, and no need to choose update frequency. In advantages, as in the paradigmatic part, the model's freshness, immediate, immediate precise data value, and no stream or even batch independent in mismatch. So we could say it's a bit high, as in the advantage part. Okay, next. Ritsuki.
So the conclusion is SAMOA is streaming is the future and is happening now, and SAMOA is a platform for mining big data streams, and it is also run on existing DSPs such as Storm, Samza, and S4, and it applies a uh, parallel algorithm for mining data streams such as classification, regression, and clustering, and it is also available and open source in SAMOA project.net, and SAMOA is a platform for collaboration and research on distributed stream mining. And that's it for the presentation. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, thank you very much for the team that has presented the Apache SAMOA.
Thank you.
Yep, it's good presentation too. And I have one question for you. The Apache SAMOA work for stream analysis, big data stream analysis.
Yes.
So, what the best part of the SAMOA that can the feature that can catch the batch file of the for example from the stream itself. It is like you said before, it's just like a waterfall that can we try to keep the data in for example, and then we process, or we do some adding some pipeline through the waterfall and then go directly to the processing side, something like that.
Maybe I could try to answer that question. From all the information I've achieved, I can say that there's a process in that part where it depends on who the user are using. So basically, SAMOA could read or understand which part of interest we have. So therefore, the mass amount of data are used to conclude what kind of data that we are interested in. I think that's my opinion on the answer you're asking, sir. Thank you so much.
Yeah. Okay. Thank you so much for the explanation.
You're very welcome.
I want to add some more information for the SAMOA.
Okay,
it also provides extension points for the integration of the new SPS. SPS is the streaming processing engine into the system, and these features allow SAMOA users to develop and distributed streaming machine learning algorithm once, and they can execute the algorithm in multiple SPS itself. So I think that's more explanation. Yes.
Okay. Thank you very much. It's very valuable information. Thank you.
You're very welcome.
Okay. Okay. Thank you, the team. You already have good presentation for today. Thank you very much.
Thank you, everyone.
Wait. And wait.